Hello everyone. Hello and welcome back to our channel. So, all excited and geared up for your re-NEET exam, right? So, you have your exam just in the next 3 days. And in this video, we are going to revise modern physics completely within 10 to 15 minutes, right? And this can be one of your highest return physics topic which you have to revise. Because the reason being there are 3 chapters particularly, and if you also include semiconductor devices, the weightage of these 4 chapters altogether is quite high in your re-NEET or in your NEET examination, right? And the second most important reason why this chapter is so important is that most of the times, at least 60 to 70% of the questions that come from modern physics are just direct formula based questions. And the questions repeat on the same concept every year. Like every year, you will get at least 1 to 2 questions from photoelectric effect. It's almost confirmed, right? So there are particularly 4 areas within modern physics in which you need to focus. So within next 10 minutes, within next 10 to 15 minutes, we are going to revise those 4 areas completely and in a quick manner, right? So the very first area within modern physics is photoelectric effect. The problem being this most of the students just overcomplicate this chapter. While NEET exam usually just tests the basic knowledge of your photoelectric effect. There are 2 main points which you need to remember. The first point being the intensity is intensity of your radiation, the incident radiation. The intensity of the incident radiation is directly proportional to number of electrons. And the second point being the frequency of incident radiation is directly proportional to the energy of photoelectrons. And most of the times, students thus just jumble these 2 pointers. So, you just need to remember 2 things in a very simple manner. The first point, which states that intensity is directly proportional to number of electrons, you just need to remember that intensity will only impact your number of electrons. Intensity is only impacting your quantity, the quantity of electrons which will actually be ejected. While frequency is directly proportional to energy. That means the frequency is actually affecting the quality of electron, the energy with which electron will leave the particular metal piece, right? So just need to remember these 2 points. First point basically indicates about quantity. Second point indicates about your quality. You just need to remember these 2 things. Then there were 3 graphs. The first graph was for intensity, the photoelectric intensity or photoelectric current and the intensity. So that was a straight line graph. And then we had seen 3 graphs. Even in the revision class, which I took over here on this channel, even on that revision class, we discussed all those 3 topics, right? So you just need to remember 2 or 3 basic terms. First is your photoelectric effect. What does photoelectric current mean? What is the incident radiation? What is the incident frequency? What is the threshold frequency? How do you actually calculate the kinetic energy of electrons which are released, right? Then the last term which you have to remember is the stopping potential, that is the reverse potential which has to be applied from the external of the metal piece to stop the emission of electron. The 3 graphs mainly were this was the first graph. This was for photoelectric current versus intensity. This was a straight line graph showing our first point, that intensity is directly proportional to number of electrons and number of electrons is directly indicates the current. The next 3 main graphs were, first was photoelectric current and potential, stopping potential, wherein we drew 2 graphs. We saw 2 graphs. This first graph was for different intensity and same frequency. Both the graphs are for photoelectric current versus potential, while the second graph for photoelectric current versus stopping potential was drawn for two different frequencies but same intensity. So this was for frequency 2, this was for frequency 1, this was stopping potential 2, this was the stopping potential of 1. So over here, the frequency of second was frequency 2 was greater than frequency 1. Over here, intensity 2 was greater than intensity 1. These were the two graphs, and the third graph was a simple straight line graph, and that straight line graph was for stopping potential, our stopping potential versus the frequency of radiation. It was a simple straight line graph, and it started from your threshold frequency. Along with these three graphs, we also studied the four laws of photoelectric effect. So this was all about your photoelectric effect. Within photoelectric effect, you just had to remember these basic things. Now, the next thing which is connected to photoelectric effect is the Einstein's photoelectric equation. Einstein's photoelectric equation basically stated that the maximum kinetic energy with which the electron will be ejected will always be equal to the incident energy, that is the energy of the incident photon or energy of the incident radiation, minus the work function. Work function you can either denote it by W or phi. And over here as well, the energy of incident radiation can be calculated by h into nu, where nu is the incident frequency of incident radiation. Work function can be calculated by h nu naught, where nu naught was your threshold frequency. Wherever or whatever term you see, be it incident frequency, incident wavelength, threshold frequency, threshold wavelength, stopping potential, kinetic energy, whichever term you see, you just need to remember this single one equation, right? And you will be able to solve the question immediately. Many NEET questions are directly a simple application of this equation. And within this equation also, you can just substitute the kinetic energy as half mv square. The question might ask you to calculate the velocity with which the electron will be ejected. Or in terms of stopping potential, this energy was also equal to charge on an electron multiplied by the stopping potential. So, if I just show you the complete formula, the complete equation will become something like this. Kinetic energy is equal to half mv square. This is equal to charge multiplied by stopping potential. This is further equal to h nu minus nu naught. This is further equal to hc 1 by lambda minus 1 by lambda naught. And then this is also equal to hc, you can just multiply c inside the bracket, c upon lambda naught, c upon lambda minus c upon lambda naught. So these were the basic things within the Einstein's photoelectric equation. And this is one of the most scoring sections. Just a simple single equation on which a formula based numerical will come. Moving forward, the next high scoring topic is Bohr model. Within Bohr model, this is the easiest part to score marks. Why is it the easiest part? You don't have to remember many formulas. You just have to remember 2 to 3 things. First, the energy of nth orbit, the spectral lines, the spectral series, and the radius of nth orbit. Only these things will suffice for your exam, right? So you just need to remember, as the value of n increase, the value of radius also increase. That is, as you move forward to a greater orbit, to a greater number of orbit, the radius will increase. That is quite obvious. And as the value of n increases, the energy becomes less negative. What do we mean by energy becomes less negative? That means more negative the energy of an electron, more strongly it is bonded to the nucleus. But as we are moving outside, or as we are moving farther away from the nucleus, the bonding of the electron will slowly and slightly become weaker with the nucleus. And whenever electron will jump from a higher energy level to a lower energy level, it will always release some energy. Whenever an electron will go from lower energy level to a higher energy level, it will always absorb some energy. You can just check the sign of the energy which I have. Over here, the energy will be released. Over here, energy is absorbed. Most of the NEET questions are based on these three topics, these three subtopics. You just need to remember the spectral series. There were 5 series: Lyman, Balmer, Paschen, Brackett and Fund. And over there, you can also be asked to calculate the wave number or wavelength. The formula for wave number was simply Rydberg's constant multiplied by nf square minus ni square. Nf and ni were simply the final orbit and the initial orbit. We just need to put in the values and we'll get the answer. Moving forward, the third topic is nuclear physics, which is your complete nuclei chapter. Within this chapter, the most common mistake is that most of the students leave it because they feel that it is a quite theoretical chapter. But I would say this is also again a scoring chapter, a scoring part. Why? Because the questions are quite direct, right? You just need to know the meaning of half life, that is the time in which anything becomes half of its original quantity. You just need to know some basic meanings and you are good to go. You need to remember the nuclear density, you need to remember the binding energy per nucleon, you need to remember the meaning of binding energy, you need to remember the formula of mass defect, then you need to remember what do you mean by half life, then you need to remember what do you mean by radioactive decay. Only these 5 things will suffice. Radioactive decay always have a decay constant, and half-life is the time in which any quantity becomes half of its original. Then there were 3 types of radiations: alpha radiation, beta radiation and gamma radiation. You just need to revise these many things in nuclear physics. Coming to the fourth and the last area, which is semiconductor device. And again, a very strong, a very scoring topic, but at the same time, for many students, it is a weak topic. Like they are not very confident in semiconductor devices. I would say that if you are weak or if you are not confident, if you are not able to comprehend properly, then I would recommend just study the basics. So what do you mean by a semiconductor? How a semiconductor is actually placed, how it is actually created, what are the two types, p type and n type semiconductor. P type semiconductors, hole are the majority carriers, n type semiconductor, electrons are the majority carriers, right? These two things can actually help you in your statement based questions. Next, so we just discussed p type and n type semiconductor. How do you actually make them, the majority carriers in both these things? Then how do you actually make a p-n junction? You just for one side, one half of the junction is p type semiconductor, other is n type semiconductor. And then within p-n junction diode, you need to study the two phenomena. First is your diffusion and second is your drift. You just need to remember in brief that diffusion always happens due to a concentration gradient. Concentration gradient means the concentration of electrons and the concentration of holes is not equal on both the sides. So due to a difference in the concentration, this movement happens. That phenomena is called diffusion. That process is called diffusion. Then drift, it basically occurs after diffusion. Due to diffusion, a fictitious electric field, a fictitious potential barrier is built up on the junction, and due to that fictitious built up, a field is set up, a electric field is set up, and due to that electric field, now movement of electrons and holes again happen in the reverse direction. Due to diffusion of charge carriers, a current that is constituted is diffusion current. Due to drift, a current that is constituted is drift current. Diffusion and drift current are always opposite in direction. The next thing which you need to remember is the biasing. So p-n junction diode can be biased in two ways. It can either be forward biased or it can be reverse biased. Forward biased, when p type semiconductor is connected to the positive terminal, n type is connected to the negative terminal, diode is forward biased. And if the connection is reversed, p type semiconductor connected to negative terminal, n type semiconductor connected to positive terminal of a cell is reverse biasing. Then within semiconductor devices, you just need to remember the functioning, the principle of 3 devices. First is your xenodiode, second is your photodiode, third is your LED. Only these 3 devices will suffice. So the xenodiode, it is basically used as a voltage regulator. Photodiode, it basically whenever a light falls on the diode, it starts constituting current. Photodiode is always used in reverse bias. You should know the reason. And the last thing was your LED, light emitting diode, right? So these are the most frequently asked subtopics which we revised right now. And in case you need any other topic, you can also post that in the comment. Now, so this was all about our revision. Now coming to the biggest mistake that students actually make in the modern physics. So they keep reading theory. You don't have to keep on reading and reading and reading. What you have to do is, because you're left with only a few number of days, what you have to do is, if you're not very confident, you just need to revise these things. You need to revise the formulas which I discussed right now in this video. After that, you need to pick up around a set of 45 questions. I would just say 45 questions. It would hardly take you 1 hour. You should pick up 45 questions from modern physics, a mixed question bank of modern physics. Try and solve those 45 questions. Within those 45 questions of modern physics, you will, start seeing a pattern. The same ideas, the same formulas, the same traps, the same mistakes keep on repeating. They will repeat. Even in at least, I would say, when you try and attempt 45 questions, out of those 45 questions, at least in 5 to 6 questions you will see a repeated pattern. Like on a single pattern, 4 to 5 questions will be there. So if you are currently scoring somewhere around 80, 90, or you're slightly touching 100 marks, this unit alone can actually increase your marks significantly. So don't commit that mistake of ignoring modern physics. It's quite easy, it's quite scoring, and it has a repeated pattern of questions. So do make sure you revise for these four things before your exam. You just need to master these four subtopics and you will be good to go for your exam. So thank you so much for watching our today's video. See you in the next video.